I'm Craig McLean and welcome to episode 15 of the Mk1 Escort RS2000 reassembly. In this episode I'm hoping to show you some of the more interesting parts that I didn't get to show you in the last episode due to issues with part suppliers. So hopefully later on I'll get to show you a bit of that. But for now we're going to move on to, again, a little bit more wiring. Now I know that's maybe not the most interesting thing in the world, but I do think in this case you might find it a little bit more interesting than previously, simply because it's going to involve bringing the wiring of this 1970s car into the 21st century. I'll show you exactly how I'm going to do that, but in the words of Bad Obsession Motorsport, we need a bracket. And here is that bracket, fully fabricated. I spent quite a few hours on this, in fact quite a good few hours, probably about, what would it be now, about maybe 5 or 6 hours I would say. By the time I've got it all marked out, bent and everything. It's surprising where time goes when you're building stuff like this. So this mounts under the dash by your right foot, so just above the accelerator pedal, up tucked under the dash. This section here follows the strengthener from the steering column mount up to the bulkhead. And then if we turn it round, there's another bracket here, and this basically fits onto a fixing in the bonnet pull bracket, but I'll show you that shortly. And when it's all bolted up, it fits absolutely solid. And on the back, all the holes are drilled for cables to run through. And you'll notice I've got these little upstands here. This was a little bit of inspiration I took from Project Binky, as I was just saying about before with the brackets. And basically what this is for is when you run your loom in, you can basically feed a cable tie underneath, run your loom along and round, and cable tie the loom back tidy to the bottom of your plate, because this is the top. The fuse boxes will fit on the bottom, this will be the top, and I'm hoping to have enough space in the middle here on top to mount the Omex engine management unit if possible. But as for now, I'm just concentrating on the fuses. So I'll build it up now, and I'll let you see it fully built up, obviously minus one fuse box that I haven't quite got as yet. And there we go. So starting from the left, we have a 4-bank relay holder, so that will hold 4 different relays. Which will probably be one for the power steering, there'll be one for the fuel pump, one for the fan on the radiator, and there's 5 altogether. There's going to be another one to put in somewhere, but I can't remember off the top of my head. I've got them all worked out. On the right we've got a simple, this is just a straightforward fuse box, so basically you have an input and output on these per fuse. So on the back you'll have maybe the input coming on one side of the pin and the output on the other, same for the next fuse and the next fuse. That's just a standard fuse box. For some of the items that are fed from the ignition switch that don't have fuses, I'm going to run them through that. Now these fuse boxes in the middle, there's going to be 2 of them, as I've said. There's going to be an identical one of these mounted right there. You can see the 4 holes for fixing it, and then obviously the holes with the grommets in are for the connections. Now what we have here is you come in on this side. This one's going to be the permanent fuse box, so one of them is going to be permanent live, fed straight from the battery on that big 70 amp cable I showed you in the other video if you've seen it. And this one here is going to be switched from the ignition. So what we're going to have is a main live coming in, and then this feeds onto this post, and then all these outgoing wires are fed directly from that that main live. So then obviously you put whatever size fuse for whatever circuit you want on your permanent side. Your outgoing cables go out on these posts here. So these are all for the permanent fed items. Now this is going to feed a lot of the heavy duty stuff as well, such as the power steering and the radiator fan, etc., because I want it coming off the incoming supply and not running off the ignition switch, because if I add all this extra load onto the ignition switch, I'll basically burn the ignition switch out. Then you bring in an earth from the body here, and then these are your circuit earths. So you've got 6 outgoing wires on the live side, or the positive side, and 6 outgoing wires on the negative side. And then the same will be replicated here on the switch side. It'll all tie in, and on the back of the board, you can see the terminals I was just on about there. That's the basic standard fuse box. And then basically I'll loom them all in. They'll all follow nicely, nice routes, cable and tying onto these little tabs I've put on. And that'll mount underneath the dash. As you look at it, it'll mount just like that, with obviously another fuse box added to it as well. so it'll be in a nice accessible area, and then I can get to it nice and easily whenever I want to change a fuse. And the other good thing about these fuse boxes as well, you'll notice I've got some little red LEDs, and when a fuse blows, apparently these little LEDs light up red to highlight which fuse is gone. That's brilliant, I think, because you know you could go around pulling all these fuses out, checking them individually, and you know it saves a bit of time. I am gonna, as well, on the lid here, I will be I'll be making some nice little stickers. They do come with some stickers. I'll show you now. I mean, they come with various different stickers, but they don't really say what I want them to say. So I'll probably end up making my own stickers that'll stick on top of each individual fuse on the cover, explaining what they're for. Same with this box, and same with the relays. I'll have a sticker on the front of the relay, telling the relay lid, telling you what each relay is for. So I'll get that stripped down now, get it primed, get it painted, and I'll show you it when it's all built back up, and I'll show you it in the car in its final position. I can start wiring it up, because I think when I get it in, I think it's going to look really smart. I really do. My only concern is maybe that the power steering motor, I'm just hoping it'll be along here somewhere. I'm hoping it's not going to foul or interfere with any of what I've just put together here. But I'm sure time will tell. If it does, I'll maybe just have to do some adjustments. But as for now, I'm really happy with that. Right, well, it's starting to come together now. As you can see, I've started wiring some of the circuits. So you'll be wondering why the stickers are upside down. Well, when this is bolted in under the dash, them stickers will actually face the right way. So far we've got relay for the fuel pump, cooling fan, power steering and front heated window. There's going to be another relay to add down here for the rear heated window. That's in the car, so I've got to add that in. And then I've connected up so far fuses in the box. I've got power steering, cooling fan, fuel pump, front and rear heated window. On the back, you can see I've started moving the cables in, and I've also put some rubber strip on the edges so that if any cables are running over that edge, we're not gonna damage the cables through to the copper. That's obviously the last thing we want. So I've started making up lights of the earths. These are to go obviously to the body, and then they connect into the main fuse boxes to give multiple earthing terminations in the fuse box. So yeah, that's starting to look nice and neat. That, you know, it's turning into a proper looking I suppose you could call it electrical distribution centre. These are, this is basically like what you would have on a modern car under the bonnet. You lift the plastic cover off and you have your multi-banks of fuses and relays, only they've been obviously designed for the car, so they're all moulded in nicely. But yeah, once we get the second fuse box here, which still hasn't come, and I've had automated replies from messages I've sent about it not coming, and it's drove me insane. All I'm wanting is the second one that I ordered that they didn't send, and what a fight I've had to get it to finally get to the bottom of it. So I'm hoping that second fuse box is here tomorrow and I can get more wiring done. So I've gone as far as I can on the bench now. I need to get this into the car now and start running the rest of the cables in. But it's really, really vital that you add all these items in. I think it's definitely a worthwhile upgrade to any classic car, and I'll explain now in a little bit of detail in layman's terms, make it nice and simple for people who maybe aren't very well, aware of fuses and relays, etc., as to why I'm doing all this and to why it's so important. So I'm going to explain, with the use of a diagram, why fuses are so important and what relays are used for. So starting off, I'm just going to draw a basic circuit. So we've got a 12 volt battery, which has a positive terminal and a negative terminal. Very, very straightforward. And let's say in this circuit we've got a fuel pump. So this little box here is going to represent the fuel pump. So this fuel pump, let's say, requires 9.5 amps. So 9.5 here. So we would generally use a cable bigger than what can carry 9.5 amps. We have what is called current carrying capacity. All cables have a current carrying capacity, and that is what that cable can safely carry. So for this, yeah, let's say we take a cable that's capable of carrying 11 amps. So we give it an earth cross to the battery, and we give it a positive cross to the battery. Under normal circumstances, that would be absolutely fine. We've got a cable that can carry 11 amps. We've got a fuel pump that's only pulling 9.5 amps. The cable can carry the 9.5 amps with ease, no problem. Now let's say this fuel pump's now got a fault. So it's now pulling 14 amps. So we're not pulling 9.5 anymore, we're now pulling 14 amps. And we've got a cable that's only capable of supplying it with 11 amps. Now we've got a big problem, because this cable will try its best to provide that pump with 14 amps, but it can't. It's only capable of carrying 11 amps. So what happens? Cable basically catches fire, heats up, the copper inside gets too hot, and over a prolonged period of time it will eventually catch fire, possibly destroying your beautiful project or whatever you've got installed. So if we take the same scenario again and we fit a fuse into it, so now we've got the same 12 volt battery with its positive and negative terminal, we've got the same fuel pump with its positive, negative and positive terminal, we've got the same 11 amp current carrying cable. So this is capable of carrying 11 amps still. But this time, in the positive cable, we add a 10 amp fuse. So that's our fuse. 10 amp. Now, if this pump, again, is running at 9.5 amps, no problem. 10 amp fuse can cope with 9.5 amps. Cable at 11 amp current carrying capacity can handle 9.5 amps. Again, let's say the pump now goes faulty. Again, it's now pulling 14 amps because maybe the windings have shorted to earth, or something as simple as the pump is clogged and it now wants more current. The cable can only carry 11 amps, as we've already said. The fuse can only carry 10. So what happens is, this fuse, or circuit protective device as we call them, basically blows safely. These are designed to break the circuit and not give any rise to danger. So now the fuse that's only rated at 10 amp is the weak link in the chain. So it blows, taking out the circuit. So your circuit is now incomplete, and you've safely removed the fault. Now what you must always remember is that the fuse size must always be less than the current carrying capacity of the cable. So if you've got a cable that can carry 20 amp, then you want a fuse less than that 20 amp, because the fuse must always be the weak link in the chain. So that's fuses in a nutshell. Now then, relays. What is a relay and how do they work? Well, this is basically a standard relay. As you can see at the top corner, this is a 12 volt relay and it's capable of switching 30 amps. This is a general purpose relay that you get in most general applications. It's all I'll be using in this Escort. You can get bigger relays that are capable of carrying more current, but this is all I require in this build. So I'll explain exactly what a relay is and how they work now. So let's say we need to switch an item in the car. So let's say it's the rear heated window in this circumstance. So there's your window with its bars in. We've got a 12 volt battery again with a positive and a negative terminal. So we give the rear heated window a negative cable, and we come this time through a switch. So we've got our symbol for our switch again, and we give the rear window a positive feed. Now, to make it more simple, I'm going to leave out fuses. Now, you wouldn't leave out fuses in the real world. In a real life scenario, you would still add your fuses into these circuits. But to make the drone nice and simple, I'm going to leave the fuses out. So this is the switch in your dash, that operates your rear heated window. This switch will only be rated at around about a couple of amps. Let's say, for argument's sake, this is a 5 amp switch. The rear heated window, let's say for argument's sake, requires 20 amps. Standard switches in vehicles don't carry large currents. They generally only carry probably a maximum of 10 amps. And let's say the cable is capable of carrying 25 amps, because we've just been talking about current carrying capacity. So now what happens is the rear heated window requires 20 amp. The cable can carry 20 amp, but when we throw this switch to make the circuit, the little switch in the dash isn't capable of carrying 20 amp. It can only carry 5. So when you make that switch, you basically melt the contacts in the switch. The switch is then useless, and we can't turn on the heated window. So how do we get round it? Well, we get round it with these. Basically, this is an electromagnetic switch. And how it works is, let's draw the same 12 volt battery with its positive and its negative terminal. The same rear heated window with its heating elements in it. Again, it needs a negative. This time we use a relay. Now what a relay is an electromagnetic switch which has got a little solenoid inside. So again, it's just a very, very basic switch. Now, the switch, we're going to use the same switch as we used in the scenario before. Exactly the same 5 amp switch in the dash. And again, give it a positive to your battery. Now, all this 5 amp switch is supplying is this little solenoid in the relay. Now this relay, as I said before, can switch 30 amps. So the 20 amp that the rear heated window requires is no problem for this relay, because this relay can switch 30 amps. And the little solenoid inside will need less than 1 amp to operate the switch. So basically all it does is, it's a little solenoid, it pulls in and out, makes and breaks the switch. So let's say, for argument's sake, this solenoid requires 1 amp to operate. So give it its earth as well. So now when we operate this switch, it pulls the solenoid in, operating the 30 amp switch. Now we simply take another positive feed through this switch. Again, this would be a big 25 amp cable. And we supply the rear heated window through the solenoid. And what happens now is, you throw the 5 amp switch, it operates the solenoid, which closes the 30 amp switch and gives the rear heated window the 20 amps. So your switch only needs to carry the 1 amp to operate the solenoid, but the 30 amp relay is carrying the 20 amps that's required to power the rear heated window. And that is basically how a relay works. Now I will point out that I'm not an automotive spark. I'm an electrical stroke domestic installation electrician. So I basically install electrical installations in houses and factories, etc. And automotive wiring is very, very different to what I do. But the electrical principles in terms of current carrying capacity, amperage, etc., is pretty much exactly the same. That's basically the reason I've been able to supply the detail I have here, because this is what I do in my role, or what I used to do in my previous role before I moved into a different role. So that's basically how a relay works and why we use them. I'll probably leave that there because I've probably bored you to death already enough. Right, while we're on the subject of safety items to be added into circuits, this is definitely another one. And what this is a fuel inertia switch. And what this does is you put it in line in your positive cable to your fuel pump, and this little device monitors if there's any vibration. So if your car is to hit a wall or another vehicle or whatever, this will sense that, you know, the sheer vibration caused by that impact, and it shuts off the supply to the fuel pump. Because obviously if you're in an impact and that impact causes a fire, which is often the case, the last thing you want is the fuel pump to continue running and fuel the fire. So this little device here, this little inertia switch, I've just had to tape the tester prongs into the bottom so I can show you exactly how it works. That's what this little device is for, is to avoid that scenario. This one here, I won't be fitting it because it's missing one of its mounting lugs. It's snapped off. And these were fitted in the Rover MG ranges. I had a few of these. For some reason I can only find this one. I fitted one to the Mini when I built the Mini. I was going to fit a Ford one to obviously keep in keeping with the car, because I am going to fit one of these to the Escort. But when I've looked into it, the ones fitted to some of the later Fords are identical to this. I've just had a look at one on eBay, and there's one that looks absolutely 100% identical to this, and it was listed as a Ford Mondeo Inertia Switch. So I think I'm just going to fit one of these because they're a nice little compact unit. So I'll show you now exactly how these work so you get an idea of exactly what they do. So if I turn the tester on, it's on continuity, it's on beep. So there you go, you can hear it beeping. So now we're driving along, fuel pump's running because we've got continuity through the inertia switch. All of a sudden we hit something. There you go, the vibrations took the beep out, took the continuity out. And if we come along, and let's say it was a minor impact, maybe it was a speed bump or a pothole or something, because these can be triggered by really bad potholes. I've had one of these trigger in the Mini when I hit a pothole once. So now we know we've come to a halt because the car's cut out because fuel pump stopped. All we do, reset it, and where we go. Right, my second fuse box is finally arrived, and I needed it today, so I was chuffed to bits when this came through the post yesterday. So I can now crack on and get this plate fitted into the car. The only issue is my label gun has run out of tape, so I've placed an order for another one of the label tapes. That should hopefully be here in a couple of days, and I can get the rest of the fuse ways labelled up. But I'll get this into the car and I'll show you exactly how it's mounted and what it looks like. Right, just for reference, before I climb in to show you the exact location of the fuse boxes, etc., and how it all fits, it's just right there under the dash above the pedal there. If I come down, you'll be able to see the front edge of the boxes. So I'll climb in now. It's absolutely horrendous working under dashes. One of the jobs I hate the most, because you end up with your head down there and your feet up here, up into the headline. And so I'll get myself in position and I'll show you exactly how it all looks. Right, this is really difficult to get at because the camera won't zoom out far enough, but that's basically exactly how the plate I made fits. So this is the strengthener here. Let me see if I can show you. This is the strengthener here for the steering, and the bracket basically follows the angle of that bracket and fixes back to it really nicely and holds all the fuse boxes and relay banks in a nice accessible location. So I'll bank round to the other side and I'll show you exactly how the bracket on the other side fits. And here we are from the other side, and if I bank round you can just see the bracket there for that's obviously your bonnet pull bracket there, and we've just picked up on the front of it with a strengthening bracket to hold everything nicely. It all looks really nice and neat. I'm pleased with that. I can now crack on and I can start getting all the outgoing cables connected up to all the items that I listed earlier. So I'll get on with that next. But that's it for wiring for today, because my back is absolutely broke with working underneath this dash. So we'll leave wiring for now. We'll move on to somewhere else and we'll keep coming back to it and doing bits and bobs of the wiring as time goes by, until obviously we've completed it all. Well guys, that's it for this episode. Just like in the end of the last episode, I've actually failed again to show you some of the parts I was hoping were going to be here on time, but unfortunately they're not here, and rather than delay another video, I've decided just to put this one out, and I've now found out that the parts that I'm referring to are actually coming this week, coming for definite, so I'm really looking forward to showing you them. I've got a fair few parts actually I can show you in an episode that I'll be putting out very soon. So watch out for that one, guys. I promise I won't bore you with any more wiring in the coming episodes. I understand it's not everyone's cup of tea. We've got most of it out the way now anyways, so we don't need to think about it for a while. So I'll leave it there. I'll leave wiring there. We'll move on to some other things in the next episode. Something a bit more interesting, a bit more exciting for the viewers, hopefully. So thanks very much for watching, guys, as always. Really appreciate all the views. You know, it's going really well. Every single month that goes by, the subscribers are going up, the views are going up, the likes are going up. It's fantastic. I never ever expected it to go as it did, and I'm even bumping into people, you know, people that I really respect a lot in different trades, and they're commenting on the videos and the car, and that really makes me feel great, because a lot of the people that are commenting are people that I look up to, people that I look up to as being master craftsmen, and to hear people like that commenting and saying well done, it's looking amazing, etc. It's a massive boost. So yeah, as I said, thanks very much for watching, guys. I'll see you very shortly.